Composite functions. Function 8, composite functions. The composite function f of g of x is a function in which the range of g is the domain of f. The composite function f of g of x is the function in which the range of g is the domain of f. All right, let's have a look at example 30. Example 30 says, let f of x be the function 4x plus 2 and g of x be the function 3x minus 4. Find a f of g. Now, f of g of x is the same as saying f, and in bracket we have g of x. So f of g of x is a function in which the range of g, which is f of x, is equal to the domain of f. So in other words, this is equal to f, and inside I'm going to have g of x, which is 3x minus 4. So f of g of x is the same as saying f, and in bracket we have what? G of x. So f of g of x is the same as saying f of 3x minus 4. Now to find f of 3x minus 4, in f, wherever I see x, I'm going to take out x and put g, which is 3x minus 4. So in f, which is what? 4x plus 2, I'm going to replace x with 3x minus 4. So this is 3x minus 4, and then outside the bracket I have 2. So this is how I would derive f of g of x. It is a function in which the domain of the range of g is the domain of f. Let's simplify. This is 12x minus 16 plus 2. I just apply distributive law. Whatever is inside the bracket is multiplied by what is immediately outside the bracket. Now this would be equal to 12x minus 16 plus 4 is minus 14. So f of g of x is a function in which g of x, in which the range of g of x is the domain of f. To find f of g of x, in f, wherever I see x, I'm going to take out x and put g of x. Next, we're asked to find g of f of x. All right, now let's write that a little better. So I'm asked to find g of f of x. Now, which is the same as saying g, and in bracket I have f of x, which is g of f of x, which is 4x plus 2. So what this is saying is that to find f of g of f of x, in g, wherever I see x, I'm going to take out x and put f. So g says 3x minus 4. So this is 3. I'm going to take out x and put f, which is 4x plus 2 minus 4. In g, wherever I see x, I take out x and put f. So this becomes distributive law. We have 12x, 3 4s 12, plus 3 2s 6, minus 4. So g of f of x would be 12x plus 2. All right. So g of f of x is a function in which the range of f is the domain of g. And to find it, g of f of x, in g, wherever I see x, I will take out x and put f. All right, example 31. Example 31 says the functions g and f are defined by f is the function 2x plus 1, g of x is 2 over 3x plus 2, where x is not equal to minus 2 over 3. And we're asked now to express in similar form the functions f of g and g of f. Hence find f of g of 2 and g of f of 3. Now, um, f of g, f of g of x. All right, in f, in f, wherever I see x, I'm going to take out x and put g of x. All right. So in f, we have what? 2x plus 1. But I'm going to take out x and put what? G of x, which is 2 over 3x plus 2 plus 1. So in f, wherever I see x, I took out x and put g, which is what? 2 of what? 3x plus 2. So in other words, f of g of x is the same as saying f of 2 over 3x plus 2. In f, wherever I see x, I must take out x and put g. So let's simplify. This becomes 2 times 2 is what? 4 over 3x plus 2 plus 1. Put this over 1. The LCM is 3x plus 2. So now 3x plus 2 into 3x plus 2 is 1. 1 times 4 is 4. Plus 1 into 1 into 3x plus 2 is 3x plus 2. 3x plus 2 times 1 is 3x plus 2. Alright, so what I should end up with is 3x plus 6 over 3x plus 2. So f of g of x is 3x plus 6 over 3x plus 2. Now, let's find f of g of 2. Now, f of g of 2 is, if I have an expression for f of g of x, so this is f of g of x. If I have the expression for f of g of x and I wish to find f of g of 2, it's simple. In f of g of x, wherever I see x, I simply take out x and put 2. So this is 3 times 2 plus 6 over 3 times 2 plus 2. 3 2s are 6. 6 plus 6 is 12. And down by the bottom, 6 plus 2 is 8. 4 into both numerator and denominator, I get what? 3. Divide both the top and bottom by 4. I get 3 over 2. So f of g of 2 is 3 over 2. All right, the next composite function we have to find is um is g of f of x. So b g g of f of x is g, and in bracket we have f of x. So in G, wherever I see x, I simply take out x and put f of x. So G says 2 over 3x plus 2, but I'm going to take out x. So I'm going to take out x and put f, which is what? F is 2x plus 1. So this is 2x plus 1 plus 2. In G, wherever I see x, I take out x and put f. G is 2 over 3x plus 2. So take out the x, replace the x with 2x plus 1, which is f. Distributive law, I'm going to end up with 2 over 6x plus 3 plus 2. This is so therefore g of f of x would be equal to 2 over 6x plus 5. And now um, g of f of 3 g of f of 3. Anywhere in g of f of x that I see x, I'm going to take out x and put 3. So I'm going to have 2 over 6 times 3 plus 5. 6 3s are 18. 18 plus 5 is 23. So I'm end up with 2 over 23. Next question. Example 32. The function g is defined by g of x is equal to x over 2x plus 1, where x cannot be equal to minus a half. Obtain expressions for g square and g cube. All right, first of all, g square means g of x. So in g, wherever I see x, I'm going to take out x and put g. All right. So g, in g, wherever I see x, I'm going to take out x and put g. So x at the top becomes what? X over 2x plus 1. So replace the x with g. Replace the x at the bottom with also with g. X over 2x plus 1 plus 1. So to find g squared, in g, wherever I see x, I take out x and put g. So really what we have is numerator, which is x over 2x plus 1, divide by denominator, which is 2 times x is 2x over 2x plus 1 plus 1. So this is numerator divided by denominator. This is x over 2x plus 1 divided by LCM is 2x plus 1. 2x plus 1 into 2x plus 1 is 1. 1 times 2x is 2x. 1 into 2x plus 1 is 2x plus 1. 2x plus 1 times 1 is 2x plus 1. So this becomes x over 2x plus 1 divided by 4x plus 1 over 2x plus 1. Alright, so this is x over 2x plus 1 multiplied by 2x plus 1 over 4x plus 1. Alright, this cancels that. So when we divide in fraction, you write about the first fraction. change the division sign to multiplication and invert the fraction that comes after, or invert the dividing fraction. So this is, so therefore, g squared is equal to x over 4x plus 1. All right. The second thing we're asked to find is to find G3. Now, G3 is the same as saying G of G squared of x. Now, G squared of x we already have, so this is the same as saying G, and in bracket here we have x over 4x plus 1. So in other words, in G, wherever I see x, I'm going to take out x and put G squared, which is x over 4x plus 1. So let's get to that. So G cube of x G cube of x. In G, wherever I see x, I'm going to take out x and put G squared. So that would be x, take out the first x and put G squared, which is x over 4x plus 1. And then now the x in the denominator, 2 times x. Take out that x and put G squared, which is x over 4x plus 1. And then plus 1. So what we end up with is x over 4x plus 1 divided by, and we have 2x over 4x plus 1 plus 1. This is x over 4x plus 1 divided by 2 over 2x. I have 4x plus 1 plus 1 into 4x plus 1 is 4x plus 1 times 1. We have 4x plus 1. So what we end up with is x over 4x plus 1 divided by, at the top we have 6x plus 1 over 4x plus 1. Therefore, G3 of x is x over 4x plus 1 multiplied by 4x plus 1 over 6x plus 1. These two cancel. So next I'm going to end up with G3 of x is equal to x over 6x plus 1. Alright, I think that's what we were asked to do. Let's just make a quick check. Alright, that's what we were asked to do when we did it. So, next question. It says function f and g are defined. Alright, so what we have is we need to find f of g of 0 and equate that to 0. Solve the equation. Now, f of g of x is f or, and in bracket, g of x. So in other words, in f, wherever I see x, I'm going to take out x and put g. So f is 3 minus 2. And then we have what? Put in g, which is x squared plus 2x plus 1. So this becomes 3 minus 2x squared minus 2 2's 4x Negative times a positive is a negative. We're having pen issues. All right, so let's do it again. In f, we have 3 minus 2x, but I'm going to take out x and put g. So that's 2 times, put in g, which is x squared plus 2x plus 1. Remove the bracket by applying distributive law. We have 3 minus 2x squared minus 4x minus 2. Everything inside the bracket is multiplied by what is immediately outside the bracket. So what we end up with is 1, because 3 minus 2 is 1, minus 4x minus 2x squared, and we're told now to equate this to 0. So the equation f of g of x f of g of x is equal to 0 is 1 minus 4x minus 2x squared is equal to 0. If you're uncomfortable working with the negative 2x squared, if you are uncomfortable, you could just multiply the entire equation by minus 1. So you would end up with 2x squared plus 4x plus 1, sorry, minus 1. Minus 1 is equal to 0. All I did there was multiply the entire equation by negative 1. So negative became positive, positive became negative. All right. Can I factorize this? This looks like something that can't be factorized. So 2 factors of 2 to give me, of minus 2 to give me 4. I don't think this can be factorized. 3. In f, wherever we see x, we take out x and put g. All right, so 2, 4, 2. 3 minus 2 is 1. Minus 4 minus 2. Multiply the entire equation by 1 minus 4x minus 2x squared. We have 2x squared plus 4 minus 1 is equal to 0. So the only way we can solve this, 2 factors of minus 1, this can't factorize. Can it? Minus 2 minus 2. No, can't factorize. All right, so therefore x is equal to minus 4 plus or minus the square root of 4 squared minus 2 b squared. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So that will be equal to minus 4 plus or minus the square root of 4 squared minus 4 times 2 times minus 1 all over 2 times a, which is 2. So this is minus 4 plus or minus the square root of, this is 16 plus 8 all over 4. This is minus 4 plus or minus the square root of 24 all over 4. This is minus 4 plus or minus the square root of, let's change this up a bit. 24 is 4 times 6, so it is plus or minus 2 the square root of 6 all over 4. So x would be equal to minus 2 plus or minus the root of 6 divided by 2. And essentially all I did was divide the numerator and denominator by 2. All right, so let's do the other one. We need g of f of x. All right, which is in g, wherever you see x, you're going to take out x and put f of x. All right, so g of f of x would be in g, it's going to be x squared. We're going to take out x and put 3 minus 2x squared plus 2 times 3 minus 2x plus 1. All right, binomial expansion, you're going to get 9 minus 12x plus 4x squared plus 6 minus 4x, and then at the end plus 1. All right, see with the numbers. 9 plus 6, 15 plus 1, 16, minus 12x minus 4x, that's minus 16x. And then we have what? Plus 4x squared. All right, so then we're asked to solve the equation g of f of x is equal to 0. So therefore 4x squared minus 16x plus 16 is equal to 0. We can divide the entire equation by 4. We're going to end up with x squared minus 4x plus 4 is equal to 0. All right, can we factorize this? I think this can be factorized. So x here, 2 here, 2 here, both of them negative. Yep, is equal to 0. Therefore, x minus 2 is equal to 0. X is equal to 2 twice. All right, next question. All right, so lastly, relationship between inverse function. We can show that if g is the inverse function of f of x, then f of g of x is equal to x. Similarly, so in other words, the composite function of a function and its inverse is equal to x. All right. Similarly, if or the composite function f of f inverse is equal to x. Similarly, if f is the inverse of g, then g of f of x is equal to x. In other words, g of g inverse of x is equal to x. Example 35. In example 35, we're asked what? Find the inverse of f of x, which is x plus 1 over x minus 2. So we have f of x is equal to x plus 1 over x minus 2. Step 1, take out f of x and say y is equal to x plus 1 over x minus 2. Alright. Step 2, interchange x and y. Wherever I see x, put y. Wherever I see y, put x. So I'm going to have x is equal to y plus 1 over y minus 2. Step 3 is to make y the subject. Alright, step 3 is to make y the subject. So I'm going to put x over 1. And if I have one fraction is equal to one fraction, then I'm going to cross multiply. So I have x times y minus 2 is equal to 1 times y plus 1. When I multiply anything by 1, it remains the same. So 1 times y plus 1 is y plus 1. We're in step 3 where we're trying to make y the subject. I'm going to remove the bracket here by applying distributive law. So this is xy minus 2x is equal to y plus 1. Get all the y's to one side. We have xy minus y is equal to 2x plus 1. So positive y comes over and become negative. Negative 2x goes over and become positive. Y is common on the left. So I have y and in bracket x minus 1 is equal to 2x plus 1. Divide both sides by x minus 1. We have y is equal to 2x plus 1 divided by x minus 1. That's step 3. And the final step is to say f inverse of x is equal to 2x plus 1 over x minus 1. Alright, so that's the first thing we have to do. Alright, so it's 2x plus 1 over x minus 1. So now the last thing we have to do is we just found the inverse. So now we have to show that f of f inverse of x is equal to x. Alright, so we have f of f inverse of x is the same as saying f, and in bracket we have f inverse of x. Alright, and all of this is saying to obtain or derive this composite, I need in f, wherever I see x, I must take out x and put f inverse of x. Alright, so let's do that. So now in f, wherever I see x, at the top, the numerator is x plus 1, but I'm going to take out that x and put f inverse. So it's 2x plus 1 over x minus 2 plus 1. That's the numerator of f. And the denominator is x minus 2. So it's going to be, take out x and put f inverse of x, which is 2x plus 1 over x minus 1 minus 2. Alright, so writing this a little differently, we have 2x plus 1 over x minus 2. That should be x minus 1. Should be 1 here. So that's gonna, 1 should be here. So that is x minus 1. It's 1, should be 1 here. And there should be a 1 here instead of a 2. 1. And then this is plus 1. That's the numerator. Divide by the denominator, which is 2x plus 1 over x minus 1 minus 2. Alright. Numerator, x minus 1 is the LCM. X minus 1 into x minus 1 is 1, so we're going to end up with 2x plus 1 plus 1 into x minus 1 is x minus 1 times 1 is x minus 1. That is my numerator. Divide by x minus 1 here. X minus 1 into x minus 1 is 1. 1 times 2x plus 1 is 2x plus 1 minus 2. 1 into x minus 1 is x minus 1 times 2. So this is x minus 1. And this is my denominator. For the numerator, I'm going to end up with 3x over x minus 1. Divide by the denominator, I'm going to end up with 2x plus 1 minus 2x. Negative times a negative is a positive, plus 2. And this is over x minus 1. So then I'm going to have 3x over x minus 1. Divide by, at the top, 2x minus 2x, that gone. 1 plus 2 is 3. So this is 3 over x minus 1, which is 3x over x minus 1 times x minus 1 over 3. X minus 1 cancels the x minus 1. 3 cancels 3, which leaves x. So therefore, f of f inverse of x is equal to x. All right, so that's the last thing we're asked to do, and we did it.